solving quadratic functions is using what we call the square root method. So that's our goal today. It says, I can solve a quadratic function using the square root method. But caution, not every quadratic function can be solved with this method. In fact, not every quadratic function can be solved with the last method that I taught you. Solved by factoring. Because is every quadratic factorable? Do you remember back in chapter 7, were there times that you tried to factor a quadratic and you could not? Were there ever times you get to say not factorable? What do you think? Am I speaking to the dead? I feel like it. I might as well go out, and just talk to the trees, because that's kind of how I feel right now. They wouldn't respond to me either. So, back in chapter 7, not that long ago, folks, there were times that you had 15 problems to do, and the directions said only 3 are not factorable. Do you remember this?
Yes.
Oh, thank you. So, we can't always factor a quadratic, so we can't always use the factoring method to solve. Any more than now we're going to learn the square root method. We can only use the square root method when we can take the square root and it works. Okay, so we got to make sure that we understand when we can use which methods. So today we're learning this one and we are going to use it. Some quadratic equations. No, would you let's make that into a box. Some, because I'm making such a big deal out of this. Some quadratic equations can be solved easily by finding square roots. Here's the two times when it's really handy to use this method. Good to use when b equals 0. When b equals 0. Remember there was that other time when b equals 0, we found out that if we're solving by graphing, if b is 0, the vertex is always the what? Remember that? The y-intercept. So when b is equal to 0, this is going to be a good method to use. Or when you have a factor times itself. A factor times itself. And we've had that happen before too. Okay? So here's our first one. Let's solve x squared equals 121. So x squared is on one side, 121 is on the other. If we were going to solve this by graphing or by factoring, we would get that 121 moved over with that x squared, wouldn't we? Isn't that what we would get it set equal to 0? We don't have to do that. We're going to leave it just like it is. We're going to say, you know what can I do to get x out of x squared? Anybody know what we can do to x squared?
Square
Square root it. Yeah, we're going to take the square root of x squared because we know that the square root of x squared is x. But if we do that to one side of the equation, we have to do it to the other side. So we take the square root now of 121 also, and we know that what number times itself is 121? 11. And negative 11. So we're going to say positive and negative 11, and that's the shortcut way of writing. There are really two solutions. X can be positive 11, x can be negative 11. So where would the parabola for this quadratic equation cross the x-axis? So we get this parabola. By the way, would it open up or open down? Open up. B is equal to 0, by the way, isn't it? If we did move that 121 over, would B be equal to 0? Because there are no x's, are there? Just an x squared and then a constant. So would we have a parabola opening up? Where would its vertex be?
0.
Remember when b is equal to 0, the vertex is the y-intercept, so it's going to be at
0.
At the y-intercept, if we move that 121 over to become a negative, and oh my gosh, it's way down here. Way down here on the y-axis is that y-intercept, but where's it going to cross the x-axis at? 11 and negative 11. Remember, the solutions are the zeros of the function, and the zeros of the function are where the parabola crosses the x-axis. We got to keep all that together. So we got this parabola opening up. It's got this y-intercept way, way, way down there on the y-axis, and it's gonna come up and cross the x-axis at positive, negative 11 and positive 11. So we found our solutions, okay? So would you circle that and put solutions? There are two solutions, two places it will cross the x-axis.
Oh, that's easy.
Okay? Let's look at number 2. X squared equals negative 64. So how do we get x out of x squared?
Square.
Take the square root of it. And the square root of x squared is x. And then if we do that to one side, we have to do it to the other side. What's the square root of negative 64?
Negative 8.
Negative 8 and 8.
Mhm.
So negative 8 times negative 8 is negative 64. That's positive 64, isn't it? And positive 8 times positive 8 is
64.
positive 64. So do you think we can take the square root of negative 64?
No.
In other words, do you think there's a number times itself that'll ever give us negative 64?
No.
No, because the only way to get a negative is if one of them is positive and the other one is
Negative.
negative. So if one of them can't be positive and the other one be negative and be the same thing. They are considered opposites then. So we cannot make this note. We stop right there. We have to stop and say, cannot take the square root of a negative number. So we're going to say, sorry x, no real solution. And we have to use the word real. Because you guys, when you're taking advanced algebra in your senior year, you're going to find out that there are other types of solutions. There are imaginary solutions, complex number solutions. So there really is a solution to this, but it's just not a real one. So we're gonna say, here's our answer. Okay? So any questions on that one? Okay, then let's try the next one. 4x squared minus 25 equals 0. Notice what I say. Get x squared alone first.
Square.
So in other words, add 25 to both sides. Let's do that first. Let's get that 25 moved over. Because if you tried right now to take the square root of both sides, does anybody just happen to know what the square root of 4x squared minus 25 is?
2x.
Close, but 2x. Yeah, this is a tricky one. It's not as easy as, you know what, well, the square root of 4x squared is 2x, but we have that minus 25 that's hanging out with it.
It'd be no solution.
Well, no, that isn't what would happen, but you know what, we'll just do this and I'll tell you what the square root is in a moment here of 4x squared minus 25, okay? So let's get the x squared term by itself first. So 4x squared is now by itself. Next thing we're going to do is we're going to divide both sides by 4 so that we get, so I said I want x squared alone. So 4x squared, divide that by 4. Take the 25 and divide that by 4, but don't go into panic mode because 4 doesn't go into 25 nicely. Relax, we'll be okay. Because tell me something about 25.
5.
It's a perfect square. Tell me something about 4. It's a perfect square. So that means I can, because we know what you do when you take the square root of a fraction. We learned that a while ago also. So we're going to take the square root of x squared and then brighten. What are we going to do with that fraction?
Take it and get the square root of each of the parts of the fraction.
Yeah, so remember what happens is we can take that 25 and give it its own radical sign. Take that 4, give it its own radical sign. When you're taking the square root of a fraction, the numerator can have the radical sign and so can the denominator. Or in other words, what we're looking for is what times itself gives you 25 fourths.
5 halves.
So 5 halves. So we're going to say x is equal to the square root of 5 is, or 25 is 5. The square root of 4 is 2. is 5/2 times 5/2. Would that get us back to 25/4?
Yes.
It would. But is that the only solution then?
No.
What's the other solution?
Negative.
Negative, so positive or negative 5/2. Or 2.5 if you want to call it that. Okay, let me tell you, I mean, just because I don't want you to think that this could be a no solution one, but yet we can find solutions. The square root of 4x squared minus 25, here's what it actually is. It is 2x minus 5 times 2x plus 5. And that's going to confuse you. You'd be like, I thought the square root was something times itself. But that, when we multiply that back out, would it get us to 4x squared minus 25?
Yeah.
What do you think? Remember what happens when you FOIL? This would get us back to that, and then we would set each of those equal to 0 and solve each of them separate of each other. But guess what? We made it a whole lot easier, didn't we? Because would you have known this?
No.
Probably not. So we made it a whole lot easier. This is the way we're going to do it right here. You don't need to worry about that. But I don't want you to think that we can't take the square root of that and that means there's no solution. I want you to instead to use this method that works. We really can. Okay? So let's go to the back side now. See what we're going to do back there. That's interesting. What do you think you should do? What would be your first move in this one? Like, go. Subtract 75? Cameron, you want to do something different?
Subtract 100.
Subtract 100. Okay. So if we subtract 75, what would we end up with?
0
9x squared plus
100.
25 equals 0. Anybody know the square root of 9x squared plus 25?
5 and 3. 3
So
3x.
3x
Plus
plus
5.
5.
Or no, 10.
Now it's 10. Okay. Well, if we move that 75 over, I just want you don't need to write this down, but I want you to see this is what we would have. And if you want to do the square root method and do this, you want to say, okay, I'm going to take the square root of that. You got to know what the square root of that is. And I don't know if we do know, Isaac.
3x plus 5 times 3x minus 1.
Okay, would this FOIL back to that?
Yes.
Ooh, let's just look at the last step. 5 times negative 5. What's 5 times
Well,
negative?
would it be 3x plus 5 squared?
So could it be this then? You're saying now, Isaac, you want to change it to this. How about that? Could it be that? How do you guys feel about that? Oh, wait a minute. Let me throw the water on that one too. If we took 5 times 3x the inside and we took 3x times 5 the outside, what would that become?
15.
15x and another 15x. That'd be 30x, wouldn't it? So this would become 9x squared plus 30x plus 25. Is that the same as that?
How about minus 25 minus 25? And then
So here's what we're going to do. We're going to put trying to after that because guess what? We can't. We're just going to put a good try. You guys have made some really good attempts. I want us instead to do what Cam wanted us to do. Let's subtract 100 from both sides. Let's get that 9x squared by itself. So we're going to have 9x squared now alone equal to what? Negative 25. Okay. Well, x squared still isn't x squared, it's 9x squared. So what are we going to do next?
divide by 9.
Divide both sides by 9. So we'll divide both sides by 9. And I'm kind of liking this because you know what? 9 doesn't go into 25 nicely, but I'm feeling really good about, I like 25, it's a perfect square. I like 9, it's a perfect square. Feeling pretty good about that. And then I go to the next step, which is what? Find the square root of both sides, so the square root of x squared and the square root of negative 25/9.
That's the struggle.
Huh. Well, so then we can give the radical sign to, each of them can have their own, right? Who are we going to give the negative to, the 25 or the 9? 25, okay, we'll let the 25 have the radical, the negative. So we're going to have radical negative 25 over radical positive 9. Square root of negative 25 is?
5.
Oh, 5 times 5 is negative 25?
Negative 5.
Oh, and negative 5 times negative 5 is negative 25?
No.
You can't do it.
Oh, you can't take the square root of a negative number. So we say,
No,
can't, will you write this in your notes? Can't take the square root of negative 25. Not going to happen. Not in our world right now. Oops, I didn't need that to be a radical sign. Can't take the square root of negative 25, or for that matter, negative 25/9. It doesn't matter. And so we're going to say what?
no real solution.
No real, that's part of it, solution. No real solution. In other words, not a number solution that lives on the number line. Remember, all the real numbers live on the number line. So there's not a number line solution for that one. There is not a real solution. Advanced algebra will teach you what the solution really is. Okay, what part of that should we go back to? So we're not even going to attempt this, remember? We're going to say, you know what, that part right there, we're not probably going to try and take the square root of binomials because we didn't spend a whole lot of time on perfect square. We did do perfect square binomials, but I'm not sure that, we can remember enough about that. This is a much easier way, and it works, so let's use it. Okay? Let's look at number 5. Should we FOIL that out? Should we take x plus 3 times x plus 3, FOIL all that out, and see what happens? We could, but then you know what's going to happen? Let me just give you a little hint. Here's what's going to happen. If we FOIL that all out, and then try to maneuver it around, we're going to have a b value that's not 0. And when b is not 0, we can't use this method unless we really know what we're doing. So let's go back to the front side and see what it said. What was the other scenario? Good method to use when b is 0, like it was in this one and another one further down. Or when you have a factor times itself. Or when you have a factor times itself. Let's go to the back here. Is this a factor times itself?
Yes.
It is. So you know what we're going to do? We're going to just go right to work saying I can take the square root of that. Because if it's a factor times itself, the square root is that factor. So what's the square root of x plus 3 times itself? X plus 3, yeah. It's x plus 3. It would be no different than if I had 16 there. Like let's say I have the square root of 16. What is the square root of 16 again?
4.
4. So could I write it like this? 4 times 4. Could I write it like this? 4 squared. And the square root is 4. No, the square root is 4, isn't it? And so the square root of this is the factor that's being multiplied by itself. So x plus 3, we're going to take the square root of 49 now. What's the square root of 49?
7.
And?
7.
Negative 7. So a positive and a negative 7. Well, how tricky is that? Have we finished solving it yet?
No.
Is x by itself? No, so we have a couple of things we have to do here. We're going to set that x plus 3 equal to the positive 7. And we're gonna set the x plus 3 equal to the negative 7, because it says x plus 3 can be equal to either the positive 7 or the negative 7. It can be equal to both of them. So now we're going to solve both of these simple little equations. We're going to subtract 3. And what's our first solution?
X negative 3.
Positive 4, x equals 4. 7 take away 3 is 4, right? And then over here, same thing, we're going to subtract 3 from both sides. What's our other solution?
X equals negative 10.
X equals negative 10. There we go. We have two places that parabola would cross the x-axis. So if we would have boiled this one out, this would have been one we would have had to solve by factoring then. So we actually would have probably made more work for ourselves. This was pretty easy, wasn't it? Okay, why don't you try the next one on your own? See if you can do it. Try that last one on your own, number 6. It's a factor times itself. When you're done, you can look up and see if you agree with me or you want to challenge me and say, I think my answer is better. Did it work for you?
Yeah.
Did you get it? Okay. So when we're solving them, we have 3 things that could possibly happen today. We're going to have when we have b actually equal to 0. If we did get the equation all on one side, set equal to 0, there would be no x's. The b would be equal to 0. So when you look at it, just like we did in these first ones, you look at it right away in the beginning. X squared equals 121. There's no x term. That means b is equal to 0. Next one, x squared equals negative 64. There's no x's. That means b is equal to 0. This one, 4x squared minus 25 equals 0. There are no x's. That means b equals 0. Remember, that's one of the times that this is a good method to try, when b is equal to 0. But when b is equal to 0 and you use this method, you can only take the square root of what type of number?
Positive.
A positive number. Or could you take the square root of 0? By the way, what if it did end up set equal to 0? Could you take the square root of 0? What times itself is 0?
0.
0. So we can take the square root of 0, can't we?
Yeah.
Okay, can we take the square root of a negative though?
No.
No, that's when we have to stop and say, okay, wait a minute now. Now I'm to the point if I'm trying to take the square root of a negative number, I can't do that. I'm going to have to stop and say no real solution. Or we look at a problem like 5 and 6 and we see that we have a factor, a binomial, that's getting multiplied by itself. It's being taken to the second power. That means it's being multiplied by itself. So what we're going to do is we're going to use the second time it says when you have a factor times itself. This method works well for that also. So we go right to taking the square root of both sides. As long as we have the factor that is being multiplied by itself on one side and the constant on the other, we should be able to just go right to being able to take the square root of both sides. But we can't stop right here and say that's our solution. We have to set up the 2 situations and get the two solutions from that, okay? So any questions at all? Any part of it not making sense? Okay, then get out loose leaf paper and get your heading.